Hello students, today we are discussing about an important rearrangement, Dienone-phenol rearrangement. Here the starting material for this reaction is this kind of dienone and the fourth position carrying some substitution. Okay, the first step is that protonation of this keto functional group. You will end up with this oxonium ion. Okay, the next step is that some kind of migration, and the driving force this kind of pi migration is that we want to nullify the positive charge over oxygen. For that, this pi bond get migrated. Okay, now you will end up with this carbocation, and this is the most important step in this rearrangement. Now, in order to nullify this positive charge, one of the fragment from this fourth position can migrate to this carbocation, that is nothing but 1 to alkyl shift, and this is mainly depend upon the migratory aptitude. If these two substitutions are alkyl fragment, then the migratory aptitude will be tertiary greater than secondary greater than primary. Suppose one of the fragment is aryl group, the important thing is that migratory aptitude for aryl group is more than that of alkyl group, so aryl group get migrated much faster than that of alkyl fragment. And you will suppose I am saying the migratory aptitude of R dash is greater than R, so what will happen? R dash will migrate over R, so you will end up with this carbocation. Finally, the stabilization of this carbocation will happen by means of deprotonation. Okay, and deprotonation will takes place, so you will end up with this phenol. So that's why it is termed as dienone-phenol rearrangement. Okay, we can discuss one illustrative example. So this is our problem, this is our molecule. So the fourth position carrying a phenyl group and an ester functional group, CO2-ET. Okay, so as we discussed earlier, the mechanism will play like this. The first step is that protonation of this oxygen, so you will end up with this structure. Alright, so migration of this pi bond will happen, you will end up with this carbocation. Now the question is that, so it is entirely different. One is phenyl group, one is carboxylate function group. So we already mentioned that migratory aptitude of phenyl is greater than that of alkyl fragment. But here we should consider the carbocation stability after the migration. Okay, so we can have two possibility. One is migration of phenyl group, one is migration of this carboxylate function group. So we can have these two possibilities. Okay, first we are dealing with the migration of this fragment, that is CO2-ET. so you will end up with this carbocation, right? This is benzyl carbocation, highly stable, right? Now the deprotonation, you will end up with this as our products. Okay, now when you think about next possibility, that is migration of phenyl group, so that what will happen? So you will end up with this carbocation, that is this carbocation is attached to highly electron withdrawing group. That's why this is highly destabilized carbocation, and this give you your minor product. So exceptionally in this problem, suppose in general we can say that migratory aptitude of phenyl is greater than alkyl group, but you should think about the carbocation stability after the migration. If there is any highly electron withdrawing group, so the exceptionally this highly electron withdrawing group migrate over other. Okay, clear? Okay.